Did you know that you can create a Bitcoin wallet or private keys without using an actual Bitcoin wallet? Today we're going to take a look at how you can create your private keys without ever touching a piece of software that is explicitly meant for Bitcoin. In fact, we're primarily going to be using pen and paper. Today we'll take a look at how to do that, as well as why it's important that this is even possible. I am Ben with the BTC Sessions, and this is your daily session.
HODL the Bitcoin.
Quick shout out to sponsors of the show, CoinKite.com. These guys just have the best damn hardware in the game. I love my Cold Card Mark IV when it comes to securing my stack, but they've got tons of other stuff too. They've of course got the block clock, open dimes, tap signers, sats cards, you name it, they've got it. And I've done a video on just about everything. I've just got so much CoinKite stuff because I love it. So be sure to check them out, CoinKite.com. Check out the store, and you can use code BTC Sessions for 5% off everything there. Up next, we have Start9.com, your sovereign computing solution. Now, I have covered how to utilize Start9 to build your Bitcoin stack, including running a full node, running a Lightning node, and running tons of other peripherals that help you with your Bitcoin journey. But you can do so much more here, namely getting your data out of the hands of corporations and into your own personal server. So be sure to check out start9.com. You can check out the Embassy OS with the Embassy One or the Embassy Pro, depending on how hardcore you're going to be about all this. But again, love these guys, and be sure to check out my tutorial as well. HodlHodl. If the following are important to you in obtaining Bitcoin, things like peer-to-peer, things like self-custody, things like non-KYC, then HodlHodl is the platform for you. You can get up and running in minutes with nothing more than a Bitcoin wallet that you hold yourself and an email address. And it can just be a dummy email address if you so choose. And you can be trading peer-to-peer with individuals around the globe. I have a full tutorial on how to utilize it. It's also integrated in Trezor Suite if you are a Trezor user, and they do have their lending platform as well, in which nothing ever gets rehypothecated. So check them out, HodlHodl.com. There's a link down below. And finally, if you're backing up any important Bitcoin wallet, get it in solid steel, friends. You don't want to be dealing with pieces of paper, because then you're subject to things like perhaps water damage or fire damage, or just misplacing the things because it's a piece of paper. So this is how I'm backing up my important Bitcoin wallets. It gives me that peace of mind. They also have things like Faraday bags and other hardware wallet solutions here. So check them out, privacypros.io/BTC Sessions to get yourself a little discount at checkout. And with that, let's dive into the tutorial. So let's start by discussing why make this video. Why is it important? Well, what I don't want this to be viewed as is a default way to create your seed phrases and your wallets, because, you know, there is room for error here. Mistakes can be made, especially dealing with pen and paper. So there are excellent hardware and software solutions to allow you to create your own Bitcoin private keys without as much room for error. However, I think it's important to note that this is possible, and I think it's important that, you know, should you be so inclined, that you try this out just once, just to kind of learn what's happening here in the background. It gives you a better understanding of how your keys are even created. So again, the impetus of why I wanted to make this video is every now and then pieces of legislation are floated that do things perhaps like restrict personal or self-custody, basically restrict or would potentially require things like licenses to utilize a Bitcoin wallet. And you use phrases, or you hear phrases like unhosted wallet, which is a silly term in and of itself. There's no such thing as an unhosted wallet. An unhosted wallet in reality is just a wallet that somebody else owns, and you don't own anything. You own an IOU. So what they're really saying is, do you have an IOU or not? Do you actually have Bitcoin? So a lot of this legislation, if any of it were to ever pass, it effectively says you're not allowed to own this. Only other people can own it for you. So I wanted to take a look at this and kind of show the silliness of what is being actually proposed. Because when you get down to the crux of it, what does banning self-custody mean? It means banning things like numbers and math and letters and words. And you're going to see why, because we're going to be utilizing today a handful of things that are accessible without ever having an actual Bitcoin wallet or software or hardware. And so we're going to go through things that are readily accessible to anybody and how you can actually create a wallet without anybody's permission, regardless of whether you can download one from the App Store or not. So what are the prerequisites? What are you going to need here? Well, you're going to need some dice. So if you have, and barring dice, you could actually be flipping a coin. So either dice or a coin. Dice is going to be much quicker if you're going to go through this whole process with me. Some paper to write, a pen. You're also going to need what's known as the BIP39 word list, which is a protocol. Whenever you create a Bitcoin wallet, there's a set of 12 or 24 words that you write down. Well, there's a certain set of words that can possibly be used in those wallets. In fact, there are 2,048 possible words that could be used as a Bitcoin wallet backup. And there's a full list of those words in order, and it is open source and accessible to all, and it's all over the internet. And so I will provide a link to that as well. And then in practice, to kind of see that this stuff works, you can download Sparrow wallet. You could download Blue Wallet. I have tutorials for both of those. We'll be using Sparrow wallet today just to kind of demonstrate that the wallet you create is a real one and does work. Now, the other thing that you will need is I'll show you some conversion tables or some websites that make it easier to do certain math. That'll just do some calculations for you. But just know that these calculations that we're doing could technically be done on paper had you the knowledge. Okay. And then the other thing is I created some documents or rather some spreadsheets that you can download for simple calculation of things so that you can just kind of expedite the process. But keep in mind that because these are online, if you would download them and then utilize them in another program, if any funds at all are going to touch this wallet, which again, I'd recommend this just be more of a practice learning situation. The other thing that I'm going to be utilizing towards the end to kind of show other options for helping create this is the Seedsigner, which I do have a full tutorial on. And the reason I'm utilizing this is just to further kind of exemplify the fact that this is built from parts that are run-of-the-mill, anybody has access to, that nobody would ever know it was for a Bitcoin hardware device. So yeah, again, you don't have to have a Seedsigner to utilize this, but I will be showing an example of how you can utilize what we create with the Seedsigner. But if you are not using the Seedsigner, then download Sparrow wallet. I'll have a link for that down below. Anyways, a little bit of a rambling intro to what we're doing here. But without further ado, let's get started on how we're even going to set this thing up. Now, one last thing I wanted to mention here is that my learning curve in this matter was greatly assisted by this excellent article in Bitcoin Magazine by Arman The Parman. This came out in August of 2021, and basically it walks you through the math of everything we're about to do, how it works, a lot of great resources. So if you're looking for like a printed version of what we're about to do, there's no better place than this article by Arman. It's spectacular, and I thank him very thoroughly for it. What an absolute legend in Bitcoin education. All right, so first up, I have some dice here, and then I've got just a card to kind of help separate them out. This is a Sats card, not really necessary to have specifically this, but hey, kudos to CoinKite for good props. Also, these dice, this package of dice is from CoinKite as well. But again, any run-of-the-mill dice you have kicking around from an old board game, whatever it may be, fantastic. If you're super paranoid, then maybe you want some like casino grade, perfectly weighted dice if you don't trust the entropy of these little ones. But, you know, again, for experimentation purposes, not particularly worried about that. Nonetheless, for each word, you're going to need to roll 11 dice, or a single die 11 times. Okay, so this is what expedites the process a little bit here, is I can roll many dice at the same time. And then finally, I'm going to have a piece of paper off to the side where I'm going to be jotting down my rolls, and I will show you how to do that momentarily. But in the meantime, what I will do is I'll open up this bag, and so I'm just going to kind of empty these out here, let them dump randomly, and then I'm just going to kind of, I want to line them up as randomly as possible. I'm not super concerned here, and just let them, I'm just letting them kind of line up along my keyboard, and we'll get an example here momentarily of what it's going to look like as we get a word. So we'll be back in a sec once I get this sorted. Okay, so I now have a bunch of dice in a line here, and what I'm going to do is I'm going to separate out 11 dice, but I'm not going to do it just 11 all in a row. I'm actually going to separate them out by 4, 4, and 3, and we'll see why momentarily. But basically what I'm going to do is I'm going to record my rolls. Now, I'm not going to record these rolls exactly as they are. I'm not recording the values 1 through 6. I'm actually recording it a different way, and I'm going to bring these dice up hopefully a little bit more visibly for you here. Okay, so the way this is going to work is you're going to record this in kind of 3 batches per word, and you're just going to put a little separation in the values that you're recording. For each die roll, it's either going to be a 0 or a 1. If the number is 1, 2, or 3 on the die, that is a 0. If the number is 4, 5, or 6 on the die, that is a 1. So we're turning it into binary. It's either a 0 or a 1, thus binary, 2 options. Okay? And so this 4, that's a 1. It's in the top half of the possible options. The 1 here is a 0. The 3 here is a 0. The 1 here is a 0. The 4 is a 1. The 4 is a 1. The 4 is a 1. The 1 is a 0. The 5 is a 1. The 5 is a 1. The 1 is a 0. Okay? So we basically have 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 0. So I'm going to write that down. We'll see what it looks like on paper. So when I write this out, it's going to look something like this. Over to the side, it is roll number 1, and then I've just recorded the binary values here. I put a little notch in between the little separation, so 4 digits, and then 3 digits. That just helps me really, you know, have a sharp eye as I'm jotting them down, and for when I transpose them later, and we will see what that looks like. But again, I've just, again, if it's 1, 2, or 3, it is a 0. If it's 4, 5, or 6, it is a 1. And I just write that down, and then I will continue to do that for each subsequent number. We're going to do this 24 times, which is why it's convenient to have a ton of extra dice. I can discard these ones off to the side and then grab the next 11, pull them over, separate them, write them down, and then I can just re-roll all of these dice once I get through them. It just makes it easier. I don't have to be rolling, you know, a single die 11 times to get word number 1. Now, the one difference is when you get to word number 24, you only need the first 3 digits. So you only need 3 dice or 3 die for word number 24. And we will get into the why later, but just know you're going to do this basically 23 full times. And then on time number 24, 3 dice only, okay? 3 digits only, okay? So we're going to jump to a little spreadsheet that I made just to kind of visualize exactly what is happening here and how we would record this on paper. All right, so here we are on a spreadsheet that I've made to be able to record your dice rolls. Now, you'll notice right off the bat that the first roll that I just did as a demo is not the same as the one that's on here. That's because I did this previously as a practice, and I'm not going to go through and re-roll 24 times over to get new values and recalculate everything, because it is an intensive process, okay? Nonetheless, we have words 1 through 24 over on the left-hand side, so I just numbered all of the rows. And then in each row, the 11 die that I rolled, I have my values, either ones or zeros, depending on what number I rolled, whether it was the top or bottom half of the 6 possible values. Now you'll notice if you go down to line 24, I only did the first 3 digits and I left the last 8 blank, and we're going to be calculating those momentarily. But more or less, this is what it's going to look like either in a spreadsheet or on paper when you do all of these values. If you want to utilize this spreadsheet, then go ahead and there's a link in the show notes where you can just download the file. I would recommend either downloading it and printing it, or downloading it and opening it with a program that's not online. Again, just best practices. And in the end, as you create this, I'd probably not recommend using it for an actual Bitcoin wallet you're going to keep forever, unless you really, really know what you're doing. But this is more, again, learning and practice purposes. Now, one other thing I'd like to mention at this point, there is no real way that you can screw up. And what I mean by this is later on, you may have things that you have to troubleshoot. You may get to the end and be like, oh crap, my seed phrase actually doesn't work. Where did I go wrong? What could I have done? And where do I jump back to kind of fix that or correct my math? Up until this point, all your dice rolls, everything that you've done, you cannot screw up. Yeah, you can record a number wrong. Maybe you rolled a 6 and you accidentally put in a 0 here instead of a 1. But in the end, all that does is it changes what word you would have for this, but the data is already written and recorded. So it has no consequence on whether or not the seed phrase works. It'll just be different entropy than what you actually rolled. Not a huge deal. So just know that you don't have to re-roll your dice if you're encountered an issue, but moving forward is where you would focus to kind of figure out if anything has gone wrong at the end. Explainer time. What is a checksum? Well, the checksum in a backup of a Bitcoin wallet or a seed phrase is the final word, in this case our 24th word. Now, what does that checksum do? Well, basically, you are taking bits of information from all the previous words, or in this case, all of the previous dice rolls, the ones and the zeros, the binaries we wrote down. We're taking all of that information, little bits from it, and we're using that to help calculate this final word. And what that then does is, when you put in your final word, it acts as almost like a spell check on what you've done before. And when I say spell check, I mean it checks for errors. If you put in an incorrect prior word, other than the ones that were originally used to create this wallet, it will warn you. It will say, hey, your checksum is invalid, meaning there's a mistake somewhere in here. And so it acts as a layer of protection against mistakes when creating and utilizing and inputting your seed phrase into software so that you can send and receive transactions. Now, we're going to be using the previous data that we have compiled here to calculate our checksum. This could, technically, if you were good enough at math and had a lot of time, could be done manually. However, we're going to be utilizing a couple different methods to do it. We'll do one now, which is the harder one, I'll say. Not that hard, just you got to be careful with the way you type. And then we'll utilize a piece of hardware that is free and open source that you can build yourself later on to kind of see another option of how to do it. We're going to be using the terminal, which you can use on a Mac and on Linux. If you're on Windows, there is a workaround, and I'll link that down below. Nonetheless, we're just going to be typing out a command. We'll be typing in our information, and we'll be generating a value that allows us to create that final word in our seed phrase. So again, it's just a mechanism to make sure you don't have mistakes whenever you enter your seed phrase moving forward. Okay, so in this example of calculating the checksum, we're going to be using the terminal. Now, I'm on a Mac. If you're on a Mac, then you just hit the Finder here. You start typing in terminal. You'll see it pop up, and that's the program you're going to be using. If you're on Linux, same thing. You can just use the Finder or the search function and open terminal. If you're on Windows, however, it's a bit of a pain in the ass. You're going to want to, you're going to have to probably use a virtual machine and run some form of Linux as a virtual machine on your computer so that you can use the terminal. Basically, this involves putting the software onto a thumb drive and plugging it in and booting from that. I'm not going to be covering that. So if you're on Windows, I am so sorry, but I will link to whatever tutorial I do find online that can help you do that if you want to go down this road. Nonetheless, we've got our values here that we rolled with our die in a spreadsheet. We've got our terminal window open, and then I've got this command copied here. And the numbers that I've put in are just as an example. It's not even the full amount of numbers that you would need, but nonetheless, it's what you're going to be typing into the terminal window. You're going to be typing echo, a single space, all of your numbers, all of your zeros and ones that you've written down, a space. This is called the pipe symbol. It's basically the straight up and down line that is usually just below the delete key. You usually have to hit shift and then that button. Then a space, and then the word shasum, shasum. Then a space, a dash, a space, 256, a space, dash, 0. Now, I know this is a lot, but you can copy and paste it from the show notes. Just be aware it says your numbers here in the show notes. Obviously, replace that text with whatever your numbers are. But yes, this is what you're going to be typing, and then you hit enter. So I'm going to start typing that here, echo, and then again, just as an example, I'll put in the first few digits here, 1, 1, 1, 1, and then I'm going to go through all the way. I'm going to type out every single 1 and 0 that I've recorded all the way through, and then the rest of this command that I've mentioned, and then hit enter, and hopefully we get back the information that we need. So we'll be back in just a moment. Okay, we are back, and that was tedious, but I think I entered it all correctly. So I'm here at the end. I've put in all of my numbers and finished the command, so you can see the pipe symbol, shasum, A256-0, all that stuff. And I just have to hit enter. Okay, so this is going to spit out a number, a string of digits to me. And what's important here is literally just the first 2 digits. For me, this is a 7 and a 2, but it could be for you 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, or F for either of these two digits. Okay, so those are the possibilities that they could be. So I have a 7 and a 2 here. Those are the two digits that I need. Now, if you want to be super sure, you would do this again. And so what you would do, again, echo all of your numbers. You wouldn't copy and paste this. You would manually transcribe again and make sure that the same output happens after you hit enter. If it does not, it means you mistyped on one of them. And I can tell you that I did mistype on one of these previously, but now that I've done this a couple of times, yes, I know that 7 and 2 are correct. But if you want to be super sure and you don't want to have to come back later and start figuring out what the hell you did wrong, do it again, just to make sure. But you will then hone in on the first two digits, which again for me is 7 and 2. So we're going to use one of two different tools to now use the first two digits of this output to fill in the final digits of our 24 word phrase, even though there's zeros and ones right now, even though it's binary. So this output is in something called hexadecimal. Okay, and we can convert that to binary. Now I'm not going to explain exactly how hexadecimal converts to binary, but I will show you a couple tools to do so. The first one is this, where literally it's this is linked in the show notes, by the way. You're converting a hexadecimal number to binary. And so you enter the number, and I'll refresh this really quick so you can see. You put in the number. So the first digit we saw up here was 7. So we just want to type that in and hit convert. And here we go. Binary number is 0111. And so over here on our template, we'll put 0111. Okay. The next one over here was a 2. So we'll put in 2 and we'll hit convert. 0010. So same thing, we'll go over here and we'll hit 0010. And that completes our 24 words in binary. Okay, so we now have 24 different words that we will be able to decipher now that are in binary. Now, this is another handy table for converting hexadecimal to binary. Now, you may be sitting here, well, hey, I thought you said it could either be a 1, 2, 3, 4, 5, 6, 7, 8, 9, or A, B, C, D, E, F. But I see 10, 11, 12, 13, 14, 15 here. Well, the way that hexadecimal works is 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Okay? So knowing that, if you had an F, you would know that the binary version of that is 1111. Okay? So that's all that's happening there. When you push it into this converter here, it's just saying, okay, well, this is what it represents, but this table shows it. So you can see we had 7 and 2. 0111 and 2 is 0010, and that's exactly what we have here. 0111 and 0010. All right, so that's all that's happening here, and that allows us to fill in the end of our seed. And that checksum is basically making sure when you go to put in your words later on that because little bits of data were used from every single word to get that checksum, then effectively at this point, if there's a typo or you put in the wrong word, it will warn you and say, hey, your checksum, your final word, is invalid. We'll get into more of that and see what that looks like in practice. But nonetheless, this is how we get our checksum. This is how we get our final word, our 24th word. Okay, so up next, we're going to be converting our binary words into decimal, which is a 4-digit, just regular number. And the way that we're going to do that is we're going to have this string of digits. So 1024, 512, 256, 128, 64, 32, 16, 8, 4, 2, 1. Basically, we're taking 1024 and we divide it in half until we get all the way down to 1. Notice that I've put a little separation in here. Why? Well, how many times did we roll the dice? 11. There are 11 different digits here. So what we're going to do is underneath these digits, we're going to transpose our ones and zeros. So just as an example, I've got my words or my dice rolls in front of me off screen here. So I'm just going to write them out. So I had a 1, 1, 1, 1. I had a 0, 1, 0, 1. And I had a 1, 1, 1. Okay, I'll put the little separator there so it's easier to see, and maybe I'll do a little line so it's easier to visualize. Okay, so basically there's ones and zeros underneath all of these actual larger digits. The way it's going to work is anywhere there is a 1, you're going to add that digit together. Anywhere there's a 0, you're going to omit that number. You're not going to include it. So I would be, this is for my first dice roll for my first word, I would be adding 1024 plus 512 plus 256 plus 128. I won't use the 64 because there's a 0. So then I'll do plus 32, don't use 16, plus 8, plus 4, plus 2, plus 1. So I'm adding most of these numbers because I only had a couple zeros. So again, I'll write that out. It would end up being 1024 plus 512 plus 256 plus 128 plus 32 plus 8 plus 4 plus 2 plus 1. So it would look like that. At the end of this, you're going to get a number, a value, and that number, and I have it off screen here, it is 1,967. Okay? So this is the number that you want to come to. Now, it'll be different for you because you may have totally different rolls than me. In fact, you most certainly will. But this is the value we want to get to. We want to add up all of the numbers under which there is a 1, but not under which there is a 0. So I didn't include 64 or 16 here. So I get this value, 1967. We're going to do that for every single one of our rolls. And we're going to jump over, we're going to look at a spreadsheet and what that might look like. And again, how you could expedite it if you just kind of want to use this as a learning tool. So let's jump to the spreadsheet here. Okay, so here's our original sheet that we had entered all our ones and zeros based on which word we were rolling for. So 11 rolls per word, 24 rows worth of words. Now I actually do have a second sheet in this document, and this sheet looks like this. I still have the 24 words laid out, but then up along the top I see the values we were just working with, 1024, 512, 256, 128, and so on. There are a couple more columns at the end. We will explain those momentarily, but for now, just ignore them. What we're going to be doing is we're going to be plunking in our ones and zeros here. Now, luckily, I have all that copied, so I can just highlight here just for ease of this tutorial, and I can go to top here and paste those values in. Okay, wonderful. So I can now see all my ones and zeros reflected here. And so what I would do is whenever I see a 1, I'm actually going to enter the value at the top of that particular row. So I can see my first roll on my first word is a 1, so I'm going to enter 1024 there. And then I would say the easiest thing to do here is to, if you're doing this from a spreadsheet and not on paper, if you're doing it on paper, then you've got some time ahead of you. But nonetheless, what you would do is wherever you see a 1 in that row, you're going to go down and you're going to paste it in. I would do, if you're doing this via spreadsheet, I would paste it in rather than typing it, because I can tell you the first time I did this, there were a few typos in there and I got incorrect values and my seed phrase would not work. So I'm just going to go all the way down here. Wherever I see a 1, I'm going to paste it in. Make sure you don't paste it in the wrong one where there's a 0. But anywhere I see a 1, there we go. So I did all my 1024s. I'm going to do that all the way down for every single value every time I see a 1. So next row, I would put in 512 up top, and then I would copy that and I would paste it everywhere there's a 1 all the way down. Okay, so we'll be back when that is all filled in. Fun fact, the tool that we previously used to convert various numbers from hexadecimal to binary, you can also use to convert binary to decimal. I know you just did a whole bunch of work doing that manually, but it's good to learn. Nonetheless, let's see an example. So our dice seed, our first one, and let's go back to the first sheet where it's just the 1s and the 0s. All right, so we have 1 1 1 1, 0 1, or sorry, yeah, 0 1 0 1, 1 1 1 1. Let's take a look at that tool. 1 1 1 1, 0 1 0 1, 1 1 1. Let's hit convert. 1967. That looks mighty familiar, because if we go to our sheet 2, it's right here, 1967. Fantastic. So you can use various online tools to do these conversions as well. But again, the point of this video is to demonstrate that you don't need fancy software to do a lot of this. You can just do it by hand. Okay, so we've got everything filled in here. We have all our values. Wherever there was a 1, that is now replaced with the value at the top of the row. Okay, now you will notice for word number 1, remember when we added it on paper, it added up to 1,967. I just have this as a formula here in the spreadsheet, just again for speed. But if I tap on it, you can see the operation that happens in that cell is equals sum, and then it's the sum of basically cells B2 to L2. So all the way from here to here. It's adding everything in between, and then I get the total here. And it's doing so for every single number all the way down to 24. Now, if you look, you may say, well, why is there this next row that every single one of these is just 1 higher than it was before? Well, I'm going to explain. We're going to be utilizing the BIP39 word list, and that's what these numbers are going to correlate with, but not exactly. Let's dive into why. This is the BIP39 word list. If you have ever created a Bitcoin wallet and you've been given between 12 and 24 words to write down as a backup, those words are somewhere on this list. You can scroll and scroll and scroll, and you can see at the end there are almost there. There we go. 2,048 possible words in this list. All right. Now, the numbers that we recorded previously correlate to that list. However, in computer terms, computers actually start counting at value 0. So if you got a 0, let's say you rolled all zeros all the way through, this would then add to 0, but this list here starts at 1. So actually 0 equals 1, or 0 is the first word. So all I've done here on this spreadsheet is I've just said, hey, this cell is the previous cell plus 1, so that it's easier to track down what word you need. Okay, so if you add everything up and it's 1967, you're looking for word number 1968. Yeah, we just got to add a little bit more confusion there. But just so you know, we're going to scroll all the way down. We're going to look for that particular word, 1968, I believe we're looking for. Almost there. And that word would be vote. And so I jump back and I'm going to write the word vote right there. There's our first word. We're now going to do this for every other word in the list. Let's take a moment. We'll be back when that's ready and we'll check if it works. All right, with all our BIP39 word numbers transcribed into the actual words, we can now see if we did things correctly. And hopefully that will turn out to be the case. And so what we're going to be doing is we're going to be using some wallet software to ensure that this is a valid seed phrase. And we won't know until we go and we put in our final word, because remember, this is the checksum. It uses bits of information from every previous word to ensure that we're putting in the information correctly. It's kind of like a spell check almost. And so if we put in the checksum and it says invalid, that means that we've made a mistake somewhere in our math at some point ever since we generated our checksum and started putting together these words and translating them into a BIP39 value and finding the word number, all of that. We know something has gone awry. So how do we do that? Well, this is where we're going to test out Sparrow Wallet. And so again, I've got a link where you can download this, but more or less once you download it and install it on your computer, you're going to hit File, New Wallet. You just give it a name, Dice Seed, whatever. We'll hit Create Wallet. And then on this page here, you're going to hit New or Imported Software Wallet. You're going to say Use 24 words. There's your 24 slots. So our first word was vote. So we're going to enter that in and hit enter. And we're going to go all the way through. We'll put in all our words and we'll come back when we're about to put in our checksum and see if we did it properly. Here we are, 23 words put in. We have one left. You can see right now it still says invalid checksum because we don't have a final word input yet. Our final word is exact. Yours, of course, will be different, but that's what I came up with. So we're going to type that in. Yes. Beautiful. So we can see now it has changed to valid checksum. So that means that all the math that we did, everything that we put together worked. It was correct. There's no typos. We have the correct words all preceding the checksum, which is exact. So at this point, we could add a passphrase if we wanted to. I'm not going to be using funds with this. I will say, again, I'll reiterate, I don't recommend this method for creating your seed, but if you do, then I would recommend adding a passphrase in this instance because you never know. Anyways, I'm going to hit Create Key Store and then Import Key Store. All right, this has all my information that I would need. I'm just going to hit Apply. I'm not going to add a password here. And there we go. This is a functioning Bitcoin wallet. We did it with dice. And we did it with pen and paper. I mean, we used a spreadsheet here, but you can do it with pen and paper. And the only piece of software we actually used that was necessary was the terminal, which effectively, like a terminal window is available on any computer that you want. It's not specialized software in any way, shape, or form. It's completing basic mathematic functions. And even still, even though we did use the terminal window, technically speaking, with the knowledge in hand, if you were pretty good at keeping everything in order, you could do it by hand. It would be a pain in the ass, but you could do it. So now we have a functioning Bitcoin wallet. And again, this could be used on any piece of open source software, anything that you wanted. But you have a seed phrase that can be used to generate addresses and all of those things. And you can receive money. Like, this is an actual address that can be used. I can send from this wallet that I created by rolling dice on my desk and writing down ones and zeros. How incredible is that? So what happens if you get an invalid checksum? Where are you going to start with troubleshooting? Well, remember, your dice rolls, even if you write down a dice roll incorrectly there's nothing that can really happen to screw it up moving forward. You just have, you incorrectly wrote down a dice roll. Not the end of the world. It will be as if you had rolled your dice for a 4 instead of a 3. It doesn't matter in the end, is what I'm getting at. Where things can go wrong or go awry is one with the checksum. Remember, I told you to maybe double check it, make sure the same value is outputted. If you didn't do that and you're getting something invalid at the end, maybe it's time to go back and check the checksum, make sure that it was correct. And in doing so, check that when you convert hexadecimal to binary, that it was correct. So when you put in those last 8 zeros and ones, that was a correct conversion. The other thing might be when you converted the binary into decimal. So our first word, we converted all our ones and zeros. We added up all those numbers, 1024 and 512 and 256, and we came out with a value of 1,967. If you were doing that by hand, or if you had errors in your spreadsheet, those numbers may have been incorrect. So you might want to check that. And then finally, in the transcription of, okay, well, I had 1967, I added 1968, and then I looked up what word number 1968 was, which was vote for us. But maybe you read it wrong. Maybe you grabbed the wrong word. So that's another part where you could check that you transcribed it correctly. So again, I'll tell you, when I did this the first time, it was not without error. So if you got to the invalid checksum screen and you're tearing out your hair, just know, so did I. Go back, try again. You'll be extremely happy when it does finally work out. I did a little dance myself. Now, I want to show another way in which you can calculate your checksum, but also to utilize your seed phrase in an offline manner. And I'm using something called a Seedsigner. So this is a Bitcoin signing device, what some would call a hardware wallet, although a little bit different from your typical fare. One of the major things about this device is that it's built from run-of-the-mill parts that you can find really anywhere. Like, this is a Raspberry Pi Zero, and it has like a camera in it that, again, I just bought as an individual part, and then a little screen that you can put on it. Yeah, and then it's just powered by like a USB, and this is a 3D printed case. So this is all stuff that, and you don't need the case on it, I should also reiterate. So the point is, in the theme of this video, is that this is all kind of permissionless. Anybody can build this from run-of-the-mill parts, or an iteration of this, which is kind of the importance of the Seedsigner project. Nonetheless, what I can do here is we generated our first 23 words with dice, and then the first few digits, or the first few zeros and ones of the 24th word. This device can be used to calculate the checksum or give you those last few digits. So what I want to do here is I'm going to go down to Tools, and I'm going to select it. By the way, I do have a full tutorial on how to use the Seedsigner if you're interested in learning about it, using it, building it yourself. Okay. Nonetheless, I'm going to Tools, and then this is where you can create seeds. So basically what we did, but via this software. But if you didn't trust the software enough to create a seed, but you wanted to calculate the 24th word, you can do that here. So you go down and it says calculate 12th or 24th word. Select. We have 24 words we're using. Select. And then you're going to type in your first word. Our first word was vote. So I'm going to go down to V and select it. And then it'll start to blank out letters that aren't possible. Like there's no words that are V and then a Q, right? So it blanks that as an option. So I'm going to go up to O, select. I'm going to go down to T. And now I can see there's only one possible option if I'm going to go with T. As soon as you see that option, you can tap the middle button to select it, or you can scroll if it's above or below what's currently selected, but I'll select that. And then it goes on to seed word number 2. If I mess up, I just navigate to the arrow at the top and I press back. But again, I'll do one more word here and then we'll jump to the end. So again, I'll go to L, and we'll go to O, we'll go to G, and again, logic is here, so I'll select it, and we're on seed word 3. I'm going to go all the way through this till I get to word 23, and then we'll see how we calculate our checksum with the Seedsigner. Okay, so I'm here on seed word 23, which is rough, so I'm going to select that one and see what happens next. All right, so it says we're now going to build the final word. The 24th word is built from 3 more entropy bits plus auto-calculated checksum. So here we do have the 3 bits of information. Those were the 3 dice that we did roll. In fact, I have them in front of me, and the 3 zeros and ones that we got was 0, 1, 0. So the way that we're going to enter that is actually, it's labeled as coin flip entropy because, again, heads or tails, you can interpret that as zeros and ones. But we know what ours were, so we're going to select coin flip entropy, and it was 0, 1, 0. And then it says the checksum is as follows: 0, 1, 1, 1, 0, 0, 1, 0. Well, that looks very familiar, along with the final word, exact. And if you look back at what our final word was, it was indeed exact. And so that means that we did everything properly previously. We're doing it again properly now. So we can hit next. And this actually gives you the option to then load the seed onto the device. I should mention that if you watch my Seedsigner video, this thing is stateless, meaning that the seed phrase will only exist on here temporarily, okay, until it is powered down. All right, and that's kind of the point of this. But you can manipulate it from here. You can use it to sign, build transactions, do whatever you want. And you can even transpose it onto a QR code for signing later if you want quick access to these keys. But yeah, if I hit load seed here and done, then this seed is now accessible. I can, if I go over to seeds here, there it is. I can see all the things. I can, you know, construct transactions, export the public keys, all of those different things. I can back up the seed and export as a QR, so on and so forth. So there's all kinds of stuff that I can do with the seed once it's on the signer. But again, the whole point of this was to show, again, free open source software and hardware with a seed phrase that I generated from dice, pen, and paper. And here we are again. I can't state how awesome stuff like this is. Just to sum everything up here, again, the point of this video was to illustrate how silly the idea of trying to ban or license self-custody of Bitcoin truly is. Because at the end of the day, Bitcoin is simply numbers and math and letters and words, and banning it or requiring licenses for it is akin to banning or licensing speech and mathematics. And so not only that, but the fact that all of this can be done with, it doesn't require specialized hardware. It doesn't require specialized equipment and software that, you know, only experts can handle. It requires some dice, a piece of paper, and a pen, maybe a, you know, a basic computer, nothing out of the norm of what millions of people around the globe, billions of people around the globe don't already have access to, either in their pocket or in their office, and a little bit of patience. And that's it. You know, anybody can access this, anybody can use it. And so the idea of banning it or requiring licensing for it is, again, for lack of a better term, is pretty silly. Now, I will say, once again, as we've gone through this process, you know, I wouldn't use this as my method for creating seeds. As it stands, you know, you can have fantastic devices out there that can, you know, not only expedite the process, but make it less akin to errors. So keep that in mind. Maybe don't put funds on this and just use it as a practicing experience. But it is very important that people realize that this is possible. And if it came down to it, you could sit in a room with dice and paper and do all of this, and nobody could stop you. The documents, the links, everything below, all of the other tutorials that may be useful to you, all of it is linked down below. So anything that you need that you see in this video, you can find it in the show notes. And with that, I hope this has been educational. Please do share it around, and let me know your thoughts in the comments down below. Thank you guys so much for watching. As always, please do like, subscribe, share. All those things help a ton in getting this content in front of more eyeballs. Now, if you want to help the show in another way, you can hit up the previously mentioned sponsors in the show notes down below: CoinKite, Start9, HodlHodl, and PrivacyPros.io for the BillFodl. Now, if you're looking for a little bit of extra hand-holding, maybe all the free tutorials that I have online aren't quite cutting it, you need some one-on-one interaction, opportunity to ask questions, all of that stuff, you can book me for one-on-one sessions through my website, btcsessions.ca, so be sure to check that out, or toss it to anybody that may find it useful. And finally, if you really liked what you saw, you can always hit me up with a Bitcoin tip at my Strike page. That is strike.me/BTC sessions. Head there, you type in any amount you want, hit the tip button. You'll be greeted by, first, a Lightning invoice, or if you prefer, tap the arrow to the right, you'll see a regular Bitcoin QR code. With that, I am out. Have yourselves a wonderful day or evening wherever you may be. See you guys next time for your daily session.
HodlHodl the Bitcoin.